Now we will see op-amp. Op-amp means operational amplifier. Okay, the symbol of op-amp is like this. Okay, so here two inputs are there, one output is there. This is the supply one, the IC supply, and this is the negative ground. Means two supplies are there, one is negative supply, one is positive supply. And another important thing is the two inputs are also known as, one is non-inverting terminal and another is inverting terminal. The positive one is non-inverting terminal and the negative one is inverting terminal. Okay, so non-inverting and inverting, what is the meaning of inverting? Inverting means the reverse. If whatever the voltage we put here, IC understand the reverse one, means just the opposite one, like NOT gate. So one example, if in inverting terminal we put 5 volt, then the IC will understand this is minus 5 volt. Inverting means the reverse, right? And non-inverting means if we put here 5 volt, then the IC will understand 5 volt plus 5 volt only. Okay, so terminals are there. One is non-inverting terminal, one is inverting terminal, one is his supply, positive supply, another is negative supply, and last one is our output. So let me move to the next. Op-amp application means operational amplifier, means in same package we can use so many things, so many types of functions. For that reason the name is operational amplifier. So the amplifiers, we can use the application of operational amplifier is normal amplifier, differential amplifier, summing amplifier, oscillator and comparator. Just the overview. So amplifier, amplify means what? Amplify means it's amplify the output. Okay, so in amplifier, one is inverting, another is non-inverting. Okay, very carefully you just listen. Inverting means if the supply, okay, if the supply goes to the inverting terminal, this is the supply Vi and this is output, these are the feedback resistor and this is in ground. So if the supply goes in the inverting terminal, so this is called amplify inverting. So output will be in this formula. If you put, then output will, you can calculate the output. Okay, so let's not focus on these things, this will not required. Okay, in inverting output will be negative, means amplifier if it is inverting then the output will be always negative, and in non-inverting the output will be always positive. The formula is there, the voltage will be in inverting means non-inverting terminal. Okay, amplifier, in amplifier you can see only one input is there and the feedback, this is called feedback also, the feedback is connected to the inverting terminal. If the feedback is connected to the inverting terminal, means it's amplifier with one input, not two input, because so many applications are there in op-amp. So let's move to the next. Another amplifier type is differential amplifier. So you see why amplifier, because the negative terminal is connected with the feedback one output, right? So in differential, the differential output will come. The formula is this one. If you put this formula into the input resistance value input, then the output will come. This is known as differential amplifier. Oscillator, oscillator is used to a particular type of output in waveform. Okay, so 2-3 rules are there. The first, one input also should be like this, otherwise the output will not come like this. First. Second, the outputs, the higher portion and the lower portion will be this and this. If this is 5 volt, then this upside will be 5 volt. If this is ground, then this will be 0 volt. So according to this voltage and this voltage, the output will come. This is the main thing. LM393 IC maximum board LM393 IC are using. Okay, we will see in schematic diagram that IC. Okay, so if no feedback is there, even feedback will be there, but still then this is a comparator. Comparator means, just try to understand, here it is written out, if V1 is greater than V2, V1 is greater than V2, negative is greater than positive, then the V0 is equal to VCC, means this one. So one mistake is also there. This will be the positive, this will be the negative. Upper side, this is the non-inverting terminal, this will be the inverting terminal. Okay, just remind it. So if in the inverting terminal is greater than the non-inverting terminal, then the negative voltage will come. Means if negative voltage is greater, then the negative voltage will come, this voltage will come. If the positive voltage will greater, then this positive voltage will come. Only this much you need to remember. Not only this much, the thing is, if the positive terminal is greater, then the output will be 1, means 0 1 0 1 logic 1. If the negative terminal is greater, then the output will be 0. This is the logic of a comparator.